Can you all hear? Okay. Okay, for today or this week, actually it's supposed to be is it the last week of the semester, right? Next week we're gonna have a revision weeks. Is that right?
Yes, doctor.
Okay. So actually we have another one lecture which is going to be on Tuesday, and for today or on Thursday. For today we are going to look at the project. Actually, I just would like to know the progress, and maybe I show sample problems, how to use Fluxys. Okay, how was your project, the progress of your project? Is it okay? Okay,
not very well, doctor.
Not very well. Okay, actually it's not that difficult. What you can do, you with your friend, of course, in a group, decide which topic you want to do, and then maybe you go to a place. Let's say you want to do a foundation. Maybe you see around where there is a foundation. Maybe somebody is building a house, and you can see the picture of the. You can see what they are doing, or maybe from pictures. Maybe your neighbor or maybe your parents used to build a house, or maybe a friend's project, or maybe your uncle's project, where they construct something. So the topic can be a foundation, for example, to design a foundation, maybe a shallow foundation, or it could be a slope, study of slope. Maybe in UKM there's so many slopes there, and there are some failed slope, or even existing slope. You just go and snap the picture, and maybe go and get the dimension or geometry. What is the height and what is the width of the problem. Then you take pictures, definitely, and then you say you want to study the stability of the slope, and then you start use Fluxys, since you have the geometry, and or maybe if you want to go detail, you can get the SI report, to see what is the strength of the soil. If you don't have that, no worry, you can just use the geology map. In geology map, it tells you in every location in Malaysia what is the soil under it. They call it geology map. So you know what type of soil in that area. So you can roughly predict what is the parameters, strength parameters to use. For example, what is the C value, what is the phi value. So you can just use the typical soil strength parameters, and it is fine. The idea is for you to get used to Fluxys environments, and able to run the problems. So the topic can be wide, because this is an open-ended solution, and the topic also open. So it can be foundation, retaining walls, slope stability, embankment, so many things in geotechnical engineering, which you have covered so far. Or worst come to worst, you can just go and look at the Plaxis getting started manual. There is a manual, and there is a topic called getting started, where there's so many problems, and it tells you step by step how to solve it. Maybe you just look at that first, and then decide which one you want to, a topic that you like, and then from that you know how to model using Plaxis, and then just go and find a place where there exists some issues there, or not necessarily issue. Somebody maybe have designed it. Maybe you check by looking at uh, the existing structure, for example, foundation or slope. Then you can just get the geometry, and then use the typical values of material. For example, what is the C, what is the phi value, what is the Young modulus, and so on. And then you can just run the software. Yeah, I think it's not that difficult. I'm not expecting you to have a really real problem currently, issue which is so current, and maybe already the thing is already there. For example, you want to check what is the slope stability for a structure, a soil there. So you can do so many things. Okay. So is there any issue to do the projects? Yeah, maybe anybody want to ask or to get clarifications? Okay. If you don't have, then I'll show you how to use Plaxis then. Okay. Okay, I hope you are able to get or access to the software. Okay. Okay, let me show the interface. Okay, to get the software, you can just Google, type, maybe you get from the get into PC. They have a lot of software for you to install. Okay, this is Plaxis 8.6. I tried to download from Get into PC. Actually, I also have the license one, but just to check whether you can do it on your own or not, I download the software and install it just for the sake of uh, to have a hands-on on it, whether you to check whether it can run or not. Okay, this is a Plaxis. When I install it, so normally when we click the Plaxis input, we will get this interface. Okay, we can just actually will pop up the general setting here. So you're gonna see something like this one. Can you all see the what I'm sharing now?
Yes, Doctor.
Okay. So when you install it, but make sure when you install from that get into PC, it tell you how to install. There is a video to install it. I just go through that, so I managed to install it in my laptop, no problem. Even if this is not the from the real Fluxys, but just for the sake of learning the software, I think no problem. But if you want to do for commercial, definitely you have to get the software, and it's quite expensive. Okay, so when you run Plexis, Plexis input first, then you get something like this one. So here you just give the name of project. Let's say I just uh, give a name, learn one, just to give a name. Okay, so this is a plane strain 15 knot and so on. The model, we can also do for asymmetry. Asymmetry is something that is the problem is similar where you can cut into half. For example, uh, when you do some excavation, and then you can just take the left side of the problem if the right side also the geometry is similar, so you can use asymmetry. But you can also, the same problem, you can also use the plane strain, except the issue is more gonna take more calculation, more times, because it is like you double the problem, where you can cut into half. Okay, so you can just use default here. So you can just click next or go to dimension. For example, a dimension here. So you can just keep it, but for geometry dimension, it depends on your problem. Let's say for this case, this is it is like your drawing. If you want, the problem is going to cover from for how the length of the problem is how much. So here the geometry of the problem, it is like 0 until 50. Some may need, for example, the width, the length of your problem may be more, but the default is for left to right 50 meter, and from bottom to top 25 meter. So that is the size, default size. You can change this one depending on your problems. And here the grid is spacing 1, and snap of interval 1, meaning that it will, when there is a grid, it will snap 1 meter. Sometimes you may want to have not a nice value, something like this one. Maybe you want to have in 1 meter, you have 2 snap, meaning that I'll tell you what snap is. I think some know, some don't know. Meaning that in 1 meter, it will snap to, so 0.5 meter, it will snap to the next one, 0.5 meter snap. If I divide it by 2, I can make it more. So 4, for example, 0.25 is snap, or 5, 0.2 is snap. Doesn't matter. Normally, let's say I just want to reduce the complexity, I just maybe put 2. So okay, the grid is too dense to say okay, no problem. Okay, why is it too dense? Okay, learn, plane, dimension. Okay, maybe we just put use the default one. Okay. I also don't know now what's wrong. Okay, let me on again. Maybe I'm using it with the big, very big screen. Sometimes they don't support a very large screen. Okay. Okay, the same thing. Uh, Actually, I extended my display. I have a two display. Uh, so this is the extended display actually, which is showing now. Okay, so when you have a general setting similar, let's say I just give name a learn one dimension. I use the default one. Okay, okay. So actually to design using Fluxys is start from the left to the right. From the left to the right. Okay, first of all we need to create a geometry. Okay, I just uh, cook the geometry. Okay, first it automatically have click on the line here. So let's say we have a geometry something like this. I click. So I have a line here from 0. Let's say I have a 5 meter, and then I don't know, maybe a 10 meter, no, 5, let's say 5 meter, and then okay, let's say the slope that I find something like this one. Okay, let's say up to here. So this snap 1 meter. Okay, so let's say I want to remove the line. I just right click. So and I can go back here also. So let's say this is the soil or the slope, and let's say I have one layer of soil up to here. Okay, so let's say this. Okay, this one, the second one is plate. So normally when we model geogrid or reinforcement, we can use this one, the plate. Let's say my structure have a geogrid here, or maybe something like this one. Right here. Okay, I have. Oh. Okay, the thing is, I use the snap function. So it is snap to other point. I can also make it for the snap here. Maybe I make it 5. So every 0.2 meter. So it is more dense. Let's say I want to have a 2 reinforcement here. Okay, something like this one. Okay. This one is hinge. This one is magnesium. Okay, this is plate. Okay, this is this is plate. This is geogrid. Let's say I just put geogrid here. Geogrid is geosynthetic material. Okay. So this is interface element. Normally, let's say soil and geogrid or a plate here or reinforcement. There is an interface element. Some people put it, some people don't use it. The idea of interface element is to smooth the calculation from soil, because soil have different strength if we compare with geogrid or uh, uh, reinforcement like steel or others. So we need to put it we don't need. Actually, it is good practice to put the interface element so that the calculation it is smooth, because different material there is an interface there, but you don't need to worry too much about that, because at the end the result is not much different whether you put the interface or not, unless your structure you are really zoom in into the problem. Let's say you just focus into this area, small area, and you want to see the interaction between the reinforcement and the soil in that small area. It is advised to use the interface element, and this is not this is for anchor. Let's say you have the anchor at the end, maybe you put it, and this is for tunnel. You want to design tunnel. Normally a slope without any structure like geogrid and plate, you can just go straight to the boundary condition. This is a boundary condition, so it will give you the boundary condition here. So this one, you can rotate, you can move only in the vertical direction but restrain in the horizontal direction. Okay, so you can actually from here, if nothing structure, it's just soil, you can just from here straight to the boundary. So it will create the boundary here and at the bottom, so that this can be analyzed structurally. So it is going to be stable, meaning that this geometry is not going to move to the left or to the right or to the bottom. Because the bottom here is fixed in the vertical and also horizontal, so it's not going to move anywhere here. This side only moves down, up and down only, not horizontal, similar to this one. So boundary condition is okay now. So we need to, if you have load, then you can put load. Let's say you want to model, I don't know, maybe you have a single load here on top. So that is the load. Maybe a structure there, or you can have a surcharge also. You can just use it. Okay, and then this one, if for the well, this is for consolidation and so on. For this problem, you can just go to the material. So material set. Okay, we have how many? We have soil, 2 layers of soil. We have 2 geogrids or geotextile, and we have 2 plates. Sometimes if you want to model foundation, you can also use plate. For example, here there is a plate, or so that you can know what is the bending moment and so on for the plate. This one is assumed the load goes directly to the soil. Okay, for material set, actually there is a global, for example here. Click global, this is the lesson from getting started. So you can just straightforwardly take this one. For example, let's say you say sand. You just want to test. So you just drag it here. And to assign, we can just click here, drag and release. So the soil at the bottom here is assigned with sand, which is property similar to the lesson 1. And then let's say I have for second soil, I just use clay. Later we go detail, and this one just to check. Okay, I can drag and release here. So we have assigned material model to the soil. And then let's say we have here reinforcement for plates. we have plates. For example, I just use a foundation. So for the plate, diaphragm wall, footing, foundation, they are using plates. You can use this model, but let's say I'm not interested, I don't know what value. For example, I can just create a new one. So I need to give the property for that plate. So they ask for EA and so on. Okay, let's say I just use for diaphragm wall. This one, because there is the anchor there. Okay, I just drag and point at the plates there, plate 1, and I release. So the color turn into red. The same thing, I drag and release at the plate. Similarly, since we have a geogrid, for this one, I can just, okay, there is a sample here. Okay, doesn't matter, let's say I want to create the new one. Why? Because geogrid doesn't have much property to input. So I can just say geogrid. Okay, and I give, for example, 1,200 kilonewton per meter, the strength. Okay, so I can just click and I can just assign. Same thing, click and assign to the geogrid. Oh, not there. Okay, so we already assigned the material for this one. Okay, for the load here, I can just click here, double click it. So point load. So I get for point load here. So X value, Y value. X value is this one. Since this is a vertical and this is assume 1 kilonewton per meter. Let's say I just want to make 5. So minus to the direction to the bottom, it is minus. It's going up positive. So Y value should be minus something. Let's say 5 kilonewton per meter street load there. So we already assigned. So this is the problem. We want to know whether this one, what is the deformation and what is the factor of safety. So for materials done, so we need to create the mesh. So let's say I click here. So it's generating the mesh now. Okay, actually it goes to my first display. I drag here. Okay, this is the mesh now. Normally this, if you look at the mesh, is triangular mesh. It is a rough, not so many mesh. We can increase the mesh. For example, we can go here, mesh. We can go global coarseness. They say now it's a coarse. Element is coarse, meaning that not many elements. We can just, let's say, try fine. Okay, so I generate. Okay, let's say I'm happy with this number of elements. It look like a spider web, nicely arranged. Okay, so I update. So after that, go to the next one, initial condition. Click initial condition. I don't know whether it's going to, this slope is going to stable or not. I don't remember what is the C and P for the soil. If not working, then we improve the soil parameter. Okay, so when in the input geometry, here, let's say if we have a groundwater table, we can click here. Okay, this is groundwater. Okay, sorry. Okay, here it is popping up this one. Okay, so gamma water normally 9.8, 10 is okay. We just use the default. 10 okay. So it is asking us to create the groundwater level. I don't know. Some they just use default, mean they don't want to consider the pore water pressure. Normally, it is about 1 meter or to 2 meter below groundwater level. There is a groundwater table. Let's say I just assume like this one. So normally we check this one. The engineer, they in real practice they have to know the location. So I can right click to off the line there. So let's say this is groundwater table. So I can just this one if you want to do some consolidation. Okay, we can just click here to get the stress, calculate the stress. Okay, so now the pore water pressure already shown here. Pore water pressure is below the water table. So the calculation is about 80, 81.5 kilonewton per meter square. The highest, maybe somewhere here, the highest. Because it depends on the height of the water table here. Okay, we update. So we can just click this traffic light button to this one is for water pressure, this side, and this side is for stress. So we click there, we want to evaluate this one. Okay, so here this is initial condition. Okay, let's say this is the initial condition, where if we look here, we don't install, as if we don't install the GeoGrid yet. If we want to install it, it is like this one. Okay, but in this case, let's say two cases we want to consider. One, just the soil without the reinforcement and GeoGrid, and also no loading, initial condition. And after that, we want to check if we put the reinforcement and GeoGrid as well as the load, is it okay or not, our slope. So I just want to know what is the stress due to the two profile, to the two layers of soil only. So I click stress. Okay. So this is the K naught. If you remember lateral earth pressure, it is calculating the K naught. K naught normally is 1 minus sine something, over 45, something like that. Okay. So it is calculating the stress now. So we get this one. This is the stress, where the stress highest is somewhere, the highest around this one. Is about 133 kilonewton per meter square. So I update. So I get actually the pore water pressure I already know. The stress in soil also I already know. So now I can just calculate. Go to the calculation. Let's say I want to save this one. Then I will be automatically got this pop-up window. So yes, I want to save it. Okay, now it show me this one. So if we look here, this is calculation. And this is input. The previous one is Fluxys input. And this is Fluxys calculation. It will automatically pop up. So here, let's say I want to have a two. One is initial condition, and I want to have another uh, soil condition. So let's say I want to create a next. Okay, the next stage of construction, this one, I want to, okay, I can just use this default stage construction. I want to define it. the second one, second phase, I want to define it. Okay, so it'll pop up this window. Okay, so it asks me what is the case now, the stage of construction. Okay, I say I want to install this one, GeoGrid. Oh, sorry. And also the reinforcement here, as well as the loading there. So there are two stages of construction. First, without the structure there, and second with the structure. Okay, so I can just update this one. Okay, so the phase one, this one without, if I go to define here, it is something like this one. No GeoGrid install, it is just blur in color, meaning that it's not installed. From here to this one, if we go to define, we see the GeoGrid reinforcement and the load is activated. Okay, so I'm using stage construction for both, stage construction, and here for both is a plastic analysis. I'm not dealing with consolidation analysis. If you want to study consolidation, you need to choose consolidation. Okay, for this case, I just would like to know the plastic deformation for these two cases. So I can just, first I need to select point. Any point here which I'm interested to know, because normally when Plexis do the calculation, it will throw, because there's so many steps, it doesn't want to remember so many results during the step of calculation, so many steps. So, but if you want to know at one particular point the result for every step, so you can pick a point. For example, I just pick up, let's say I want to know what happened here, point A here. So I update, and then I calculate. So the calculation is being done here. So it's taking time also. I hope the rain, now outside is raining. What is the idiom, like cat and dog? So very heavy outside. I hope you still manage to hear me. Okay. Okay, it seems if we look here, is the right, meaning that it's okay. Both okay. So we can, let's say, see the first model. We click the phase one and click output. Okay, here is the deformed shape, exaggerated, up to 100 times, 100 times exaggeration. So the slope is going, this is the up here, and then the red color is the after the construction. This is what happened. It will move to the left here, but this one is exaggeration. Okay, we want to know what is the total displacement. So it will show us like this one, or we can change using the shading. So it tells us which one is critical. So the critical part is this one, 70 millimeter, not much, about 1.7 centimeter, the deformation around here. Mean the wall displays 1.7 centimeter to the left, this area. So you can see now the shading of the displacement in millimeter. So you know here this is a lot, lesser and lesser and lesser. And you can see here the boundary condition here is okay. It